Hello, I'm here to discuss a soil scanning technology called TerraMap. My name is Guy Kirkwood and I'm considering using this system on my farm in Devon. You can't improve what you don't measure. The fact that this is a misquote from Peter Drucker doesn't make it any less powerful. Drucker was talking about general management, but what applies in other industries particularly applies in precision agriculture. Data is king, and of course, data requires measurement. Nowhere is this more important for farming operations than when, according to research by Dungate et al. In 2012, considering soil nutrient dynamics through soil analysis. There are numerous options to carry out soil analysis. For instance, George in 2020 identified solutions from companies such as DroneAg, Skippy Scout, small robot company Manterra, and Hutchinson. These technologies and others vary in how sensitive they are, from remote sensing for a broad brush approach, as in the G et al. Study of 2011, to very fine detailed analysis through X-ray fluorescence spectrometry, as carried out by Weindorf and Chakraborty in 2020. The key is to determine the accuracy required for any particular task, not only based on the technology available, but also on a careful cost-benefit analysis to assess its applicability and suitability. The technology from Hutchinson in the George study was called Omnia TerraMap. It's white-labelled from Canadian business Soil Optics. It consists of a gamma-ray scanner mounted on the front of a utility terrain vehicle, or UTV. Mahmoud et al. In 2013 described gamma-ray spectroscopy, also known as radiometrics, as being a promising way to provide information on soil properties at a high spatial resolution. This short presentation and the supporting paper seeks to answer the question, is Omnia TerraMap efficacious and suitable to help improve UK arable operations? It looks at the background to its creation and the development issues and challenges. It critically assesses its value and concludes whether it is suitable for the current and future challenges for arable production. The TerraMap system is to date the highest definition soil analysis scanner available. It achieves this by using a cesium iodide CSL crystal with a scintillator to measure the amount of naturally occurring gamma radiation. The gamma radiometer measures the energy in a spectrum, which allows it to identify individual isotopes within the soil. The crystal itself is housed in a non-contact, pre-calibrated sensor mounted to the UTV 60 centimetres from the soil. It can operate at speeds of up to 20 kilometres an hour, and every pass in the field covers a 12-metre wide swath. The sensor measures natural geological properties emitting from the soil's decay. This consists of cesium-137, uranium-238, thorium-232, and potassium-40. As demonstrated by Adamchuk et al. In 2021, the overriding advantage of this type of scanning compared to more traditional soil sampling methods is that it takes 355 data points per acre. This compares to just one sample point per acre with the normal lab-based sampling systems, a sampling scheme, incidentally, that's been recommended in farming literature all the way back to T.R. Peck in 1967. By way of illustration of the difference this makes, this is the pH analysis carried out by Adamchuk's team from manual soil sampling taken earlier in 2015, and this is the result using TerraMap. I'll show you that again, it's so impressive. Here to here. This is great for pH, but what else can be measured? In a Canadian experiment carried out by G et al. In 2019, the TerraMap system was used to predict soil organic matter, pH, line buffer capacity, and concentrations of phosphorus, potassium, calcium, magnesium, and aluminium. In addition, Hutchinson reports that the system will identify soil texture, sodium, boron, copper, iron, zinc, sulfur, cation exchange capacity, and plant available water. The soil optics prediction algorithms are a trade secret, but in the G study, the data was analysed using partial least squared regressions to predict soil properties from individual sensors, and different sensor combinations were in turn tried using sensor data fusion to identify the best sensor combination. Once this had been achieved for each soil property, the predictive capability was compared using different data mining algorithms, including support vector machines random forest, multivariate adaptive regression splines, and regression trees. In that study, G's team found that the support vector machines, or SVM algorithm, provided the best predictions when compared to manual sampling. From a UK perspective, the Omnia proposition, according to Wilson in 2021, is currently the only proximal scanning technology that is able to be used to determine soil organic carbon properties. These include active carbon and organic carbon, both by percentage and tonnes per hectare. This is really innovative and potentially helpful for farmers moving to environmental land management, or ELM schemes, as the basic farm payments scale down towards 2027, and as we know, they're then withdrawn for good. It's also why I'm investigating whether the technology could be suitable for our 670-acre farm. If we can determine the levels of active and organic carbon as of May 2022 to prove how they're improved by 2027, based on our moves towards more regenerative agricultural practices, we can demonstrate public good under the ELM schemes. DEFRA has said that the purpose of ELM is to provide public good for public money. And it has to be, and to be blunt, if I can prove one, I want the other. But it's not all rainbows and unicorns. In fact, there are 3 kickers outlined by G in 2019 that fundamentally affect Omnia's applicability. First and most critically, TerraMap still needs manual lab-based soil samples to be carried out to check what the algorithm predicts is proven by ground truthing. This dramatically slows down the results and calls into question the entire rationale of the system. According to Oliver Wood, Hutchinson's precision technology manager, in an interview I carried out with him in March 2022, there are 2 reasons for this. One is that there is not yet a large enough database for the soil optics algorithm to operate without real-world checking. And 2, the reinforcement learning model that they're creating is not yet ready. Secondly, the system is expensive. At £47 per hectare in a quote I received from Hutchinson, do I really want to spend an extra £12,000 when every other input price is at historic highs? And thirdly, in an interview I carried out with Nigel Warner of RAU in February 2022, he said that in any case, almost no existing farm machinery can take advantage of the data that Omnia produces. Only the most modern sprayers and spreaders with auto multi-section control, or green eye technology for green on brown and green on green operations, will be able to use the data effectively. Every other spraying and spreading machine is like using an axe to perform open heart surgery. In conclusion, does Omnia TerraMap work? Yes. It's an exciting technology with the potential, particularly in the UK, to be positioned as a way to prove in the coming years that farms can become carbon sinks rather than carbon emitters. Am I going to use it? No. Until the need for manual soil sampling is obviated by improved prediction rates, and until standard sprayers and spreaders can be economically retrofitted with green eye or equivalent technology to improve accuracy, the current limitations are just too great to justify the expense. I believe that TerraMap's time will come if the government is serious about its ELM schemes. In order to facilitate take-up, I recommend that DEFRA should include this type of technology in its farming equipment and technology fund list. This would be an effective endorsement and would provide a monetary incentive through a grant to farmers to offset some of the costs of scanning, subscription and implementation. Further, existing farm software companies such as Landmark, Farm Data, Farm Plan, AgriData, etc. could be educated as to the potential benefits of TerraMap in order to accelerate adoption through partnerships with these firms, so that all companies might benefit from what Guggenberger in 2021 described as positive network effects. These are both areas that could and perhaps should be a focus of future academic research for ATSM students at RAU. Thank you very much for listening.